Hi, good morning, everyone. So today we're going to talk about real numbers. Last time we start for models and how is contacting with our real world. Today we're going to talk about real numbers. So here, P2 real numbers. Okay, so real number system is made up by different kind of numbers. We're going real numbers is a big block, a huge block. This block has, we can study it uh, by studying the small block that made the real numbers. So the types of numbers that make up the real number system are, so here I can say the types of numbers that make up the real numbers system or first one is the natural number. Natural number. What is the natural number? Who have any idea from high school about natural number? What is the natural number?
Is it all the positive numbers?
All positive numbers. What about 1/2? 1/2 is a natural number?
No, that's a rational number.
Rational. So I can say here, not all positive numbers is all the numbers of the form 1, 2, 3, 4, 5 to infinity. So all numbers of this form 1, 2, 3, 4, 5, 6, 7 to infinity called the natural number. All of them positive. Okay, all of them positive. The zero is not a natural number. The zero is not a natural number. The second type of numbers that made up the real numbers are called the integers numbers. Integers numbers. What is the integer numbers?
Integers are any positive or negative numbers, including zero.
Like what? Which
Negative.
number? 1/2. Again, 1/2 is an integer number?
No. No.
No. So I can say it is the natural number with the negatives and the zero. I mean, for that, the numbers of this form, dot, 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 comma, -3, -2, -1, and the 0, and 1, 2, 3 to infinity. So all natural numbers and the negative of the natural numbers and the 0. This is called integers numbers. Okay? The third type of numbers are called the rational numbers. Rational numbers. What is the rational numbers? Any idea?
It's when you have let's say you have a fraction or you divide by a number, it has no remainder, or
Exactly.
or it stops at a certain
No,
point.
it has a remainder, but any number I can write it as a fraction. Or I can say they are the number of the ratio of integers. I mean, ratio of integers, like any integer over another integer, like -3 over -5, 0 over 3, 5 over 200. So the ratio, again said here, are the ratio of integers. I mean, for that, I can set R equal M over N such that M and N are integers. Can I set N equals 0 here? Can I plug the 0 instead of N? Can I set 5 over 0?
Yes, you can,
No.
because it's part of an
It's
integer.
but it's a part of integer, but I can divide by 0.
Right. No, you
No.
can't.
No, I cannot. Why? Why I cannot divide by 0? What's they give me?
Because
Ah.
it will be
Never mind.
undefined.
Undefined, exactly. So here I can say and cannot be 0. So I cannot divide by 0. They give me undefined number. So here I can define it the rational numbers as R equal M over N. M and N, both of them are integers, but the N cannot be 0. I mean, for this N. Why? Because if I divide by 0, they give me undefined number. I cannot divide by 0. I cannot divide by 0. So example for rational number, something like this, R equal 1 over 2, 5 over 7. This is rational. 20 over 11. This is rational. What about the 5? The 5, number 5, is a rational number? Is the 5 is a rational number?
That's a natural number.
Yeah, rational number.
Is a rational number also? It's why 5 is a rational number?
Yeah, because let's say 5.0, that's still 5.
5, okay, but 5, can I write it as a fraction? Something like that. M
Yeah.
over N.
5/1.
Exactly. Thank you. So the 5 is rational number. Why? Because the 5, I can write it as 5 over 1. So 5 over 1 is a fraction. So any fraction is a rational number. So the 5 is rational number. Okay. Now the fourth set that make up the real number is called are called the irrational number. Irrational numbers. What is the irrational numbers? Any idea?
Pi
Or
rational because it is repeating. Well,
exactly repeating, and what else? The pi, can I write it as fraction like this here?
No, you can't write it as a
No,
fraction.
exactly. So the irrational number is a numbers cannot written as the form m over n. So I cannot write it as a fraction. These numbers are called irrational numbers. Or like some student, they said, the irrational numbers, if I put it in the calculator, they give me like huge big numbers with decimal are not repeated. Like the pi, for example, equal 3.14, and decimals, this decimals means the number is irrational. But if I have, for example, 2 decimal or 3 decimal, like for example, 5.1, 5.1 is rational number because the decimal are stopped. We can stop after the 1, 5.1 or 5.2, or for example, 10.20 or 10.99. These all numbers are called rational number because the fraction, I mean the decimal after the point is stopped. But the irrational number cannot be stopped. They give me huge big numbers. Or if the number are repeated, for example, 2 point like this, something like that, 2.4, and the 4 repeated. I mean, for that, this is equal 2.4444444. This is rational number. But if the number 4 are not repeated, for example, 2.4567, 2, 1, 3, and go on, this number is irrational number.
Wait, so if the same number is repeating, it's rational, right?
Is rational. If the number is repeating, it's called rational. So here in the example, here 2.4 and the 4 is repeated. Repeated means the bar here above of the 4. And again, this number here equal 2.4444 to infinity. 2/3 is irrational number. Why? Because the same idea. Here I get a question from Ahmed. 2.2/3. I mean the 0.66666. This is also a rational number because the 6 repeated. But if the number is not repeated, like this example, 2 point here, 2 point, I put it correctly here. This is point 2.4567213 and go on. This is not repeated, so is irrational number. Another example of irrational number is the pi. But let me first define what is the meaning of irrational number. So I can say any number cannot be written as a fraction. Any number cannot written of the form m/n. Cannot written of the form r equal m/n. Example for that, like I said, the pi. Can I go to the next slide? Can I move to the next slide?
Yes.
Okay.
Yeah, move on, please.
Okay. So next slide here, for example, the pi 2.45213556 and the decimal repeated, not repeated, I mean, go on. Another example, square root of 2. If you do square root of 2 in the calculator, they give me like a huge big number and the number not repeated. For example, another example, the third root of, square root of 3 is the same idea. Cannot be written as of the form m/n. So all these numbers are called irrational numbers. Now I can draw a diagram like this. I get here question, can an international number be any decimal? What is the meaning of international numbers? What is the international numbers? What do you mean for irrational? Can an irrational number be any decimal? Yes, if the number look like this, 2.4521356, and the decimal go on, continue, does not stop, this is mean irrational number. Make sense? Now let me graph a diagram for all real numbers. All these blocks, the rational and irrational and natural and integer numbers are make up the real numbers. So the pi is a real numbers, 2.4512 to infinity, this is a real number. Square root of 2 is a real number. 1 is a real number. Minus 3 is a real number. So all these numbers are called real numbers. So here I can say this is the real numbers, the big block here, real numbers. This is the real numbers. Here I can divide it into 2 pieces, this box. So the first piece is the rational numbers, and the other one is irrational numbers. Irrational. So here, irrational numbers. And inside this block is the rational here. Inside the rational, we have two things. First one is the integer numbers, and inside the integer numbers, we have the natural numbers. So here inside, we have the integer numbers. Integer numbers. And inside this one, here we have the natural numbers. This is the small one. Okay, so again, this is all this are the real numbers. The real numbers have irrational numbers, they have rational numbers, they have integer numbers, they have natural numbers. Again, the natural numbers is inside the integer numbers. The integer numbers is inside the rational numbers. There is no relation between irrational numbers and rational numbers. So the union of rational numbers and irrational numbers, they made up the real numbers. Make sense? Okay. Any question for this one? Any question? Okay. Okay. So now let's go to the properties of real numbers. So here I can say properties of real numbers. So first property of real number is called the commutative property. Commutative property. So the commutative property is telling A plus B. Here I can set A, comma B are real numbers. I mean here are real numbers. So A, the letter A and B, both of them are real numbers. So suppose I have two real numbers, A plus B. This is equal exactly B plus A. And the same things for multiplication. If I multiply the first one with the second one, is the same as multiplying the second one with the first one. Here, this is mean the order does not matter. I mean, if I add the first letter, first number to the second number, is the same exactly in real numbers by adding the second number to the first number. And this is exactly the same for multiplication. If I multiply the first number to the second number, is the same exactly like multiplying the second number to the first number. So example for this, suppose my real number are 2 and 3. So A is 2 and B is 3. 2 plus 3 is the same exactly like 3 plus 2. And the same things for multiplication. 2 times 3 is the same exactly like 3 times 2 in real numbers. Okay. So why this is correct? Because in this side, okay, why this is correct? Because if I add the first one to the second one, 2 plus 3 is the same by adding the second one to the first one. 2 plus 3 is 5 and 3 plus 2 is 5. Both of them, they give the same answer. Same things here, 2 times 3 is equal 6 and 3 times 2 is equal 6. So the both of them, they give the same answer. Second property, number 2, is called the associative property. Yeah, the properties. What is this property said? It says if I have A plus B, parentheses, plus C, is the same exactly like A plus, open parentheses, B plus C. So here I can add the C to the real numbers. A, B, C are real numbers. And the same things exactly for multiplication. A times B is the same times C is A times B times C. So this is mean does not matter which two we add first or multiplying first. So if I add this is first and then I add the result to the C is the same exactly like by adding the 2 in the back, then the result added to the A. Same things for multiplication. If I multiply the first two terms, then the result multiplying by C is the same as multiplying the second two term, and the result multiplying by the first term is A. So I give you example for that. So 2 plus 3 parentheses plus 5 is the same exactly like adding 2 plus 3 plus 5. 2 plus 3, they give me 5. 5 plus 5, they give me 10. So on this side, they give 10. But here in the parentheses, 3 plus 5 is they give me 8. And the 8 added to the 2, I mean 3 plus 5 is 8. 8 plus 2 is 10. And here the same exactly, 2 plus 3 is 5, plus 5, they give me 10. So on this side, they give 10, and on the other side, they give 10. So this is correct. For the multiplication, 2 times here time 3 parentheses times 5 is the same as 2 times 3 times 5. So the first things in the parentheses, 2 times 3, they give me 6. 6 times 5, they give me 30. The other side, 3 times 5, they give 15. 15 times 2, they give 30. So on this both sides, they give the same answer. So the associative property are achieved in the real numbers. Third property is called distributive property. Distributive. What does that mean? Suppose I have A times B plus C. So I can distributive
You just paused. Hello?
You froze, you guys?
Yeah, yeah.
Yeah, I think he froze.
He froze
And
himself.
I went out.
Damn.
Can he still hear us?
Uh-oh.
Wait, like, can he still hear us?
Yeah, because the class is being recorded.
Oh. Shush.
And guys,
I think
remember,
he probably stopped because he was the one recording it, and once he left, it probably stopped.
yeah, someone do Discord. Somebody make an account or something, and
No, it's still recording because it literally says recording on the screen.
Oh, that I didn't
Yeah.
even see that. I'm sorry.
it's recording. Yeah.
So he
Shush.
doesn't want us to drop our numbers because then when he posts it on YouTube, they're gonna see your number.
Oh,
Yeah,
no.
No,
that's
don't
true.
post your numbers on it. Just like a Discord link or something, so we all can.
Yeah.
So he's gonna make it.
Somebody make it and just
Are
drop
you
the
guys
link.
hearing this too?
That was quick.
G looks.
Hello. Can you hear me?
Yes.
Sorry for that.
No problem.
Yeah, connection is bad here. Okay, the third property is the distributive property. Okay. Okay. Third one is the distributive property. So the distributive property, again, like I said, if I have three letters, A, B plus C, so I can distribute the A inside the parentheses. So here I get A times B plus A times C. So the A, I can go inside the parentheses. Okay. For example, for this one, or the same things if I multiply the A in the back. So if I have parentheses, B plus C, and this is times A. Same idea here. So I can distribute the A inside the parentheses, A times B and A times C. So they give me same things, A times B plus A times C. Is it clear? For example, for this is, suppose I have 2 times x plus 4. Who will do this one?
I'll do it.
Okay,
So 2 times x, 2x plus
2x.
2x plus
Okay,
2 times 4.
exactly. And what is the, how can we simplify it? 2 times x is 2x plus what?
8.
8. Because 2 times 4 is 8. Okay, another kind of distributive property, if I have something like this, if I have A plus B times C plus D, so I can distributing the A inside this parentheses, A times C and A times D. The same things for the other one, B times C and B times D. So this give me A times C plus A times D plus B times C plus B times D. So example for this one here. Example. Suppose I have 2 plus 3 times 4 plus 5. Who will do this one? Who will do this one? 2 plus 3 times 4 plus 5.
Hold on.
I'll do
Yeah.
it.
Oop,
Okay. No, yeah. Okay.
Okay, so 2 times 4
2 times 4
plus 2 times
plus
5
times 5
plus
plus
3 times 4 plus 3 times 5.
perfect.
Man, that was just way too complicated.
So the same things, 2 times 4 plus 2 times 5 plus 3 times 4 plus 3 times 5. And the answer simplified, 2 times 4, they give me 8 plus 10 plus 12 plus 15. 8 plus 10 is 18, 18, 20, 30, 40, 45. So the answer is 45. Eric and Ahmed, this is correct, 45. Is it clear, this one? Distributing property?
Yes.
Okay. Okay, let's go to the next slide. Can I move to next one? Why you did not add 2 plus 3? Yes, this is correct. But I would like to use the property here in the above. So I can add 2 plus 3 to give me 5. And I can add here inside the parentheses 4 plus 5 to give me 9. And I multiply the parentheses with the other parentheses. So 2 plus 5, 5 times 9, they give me 45. But I would like to applying this here. I would like to applying this star here by multiplying, by using the distributive property, by multiplying the A with the other parentheses and multiplying the B with the other parentheses. Okay, Eric. Make sense? Okay. Now let's go to the addition and subtraction property. Addition and subtraction So the property of negation, but so here, so we have some properties for this one. The first property said, number one, minus 1 times a is the same as minus a. For example, for that, if my a as any real number, for example, like minus 1 times 7 is they give me minus 7. So if I multiply the minus 1 with any number, they give me the minus this number, the same number. Second property, if I have minus times minus a, this is give me the positive of a. Example, minus of minus 7, because we multiply the minus with the minus, they give positive 1. So I get here 7 positive.
It's like opposite sign.
Number 3. Yes.
Opposite sign, it's all,
Opposite of the sign.
and the same sign is positive.
Yes, we do the opposite of the sign of inside the parentheses. The third one, if I'm multiplying minus a with b, this give me a times minus b, and this is the same as minus outside of a times b. So the minus can move to the second number, or can we move it outside and multiplying the both of the numbers? Example for that, minus 7 times 2 is the same as the 7 times minus 2 is the same as minus of 7 times 2. Okay. Fourth property, minus a times minus b, this is give me a times b. Example, minus 7 times minus 2 give me 7 times 2. They give me 14, because here they give 14 the side, the other side they give 14. Number 5, minus of a plus b, this is equal, we distributed the minus inside the parentheses, so I get here the minus to the a and the minus to the b, so I get minus a minus b. Number 6, oh, before I go to the number 6, let me give example, minus of 3 plus 4, we distributing the minus inside the parentheses, I get minus 3 minus 4. Number 6 is the minus outside and a minus b. Again, I distributing the minus, I get minus a plus b, and this is equal, because we study the commutative property, the previous one, I mean like in the previous slides. So minus a plus b is the same as b minus a. So example for that, I have minus of 3 minus 4. This we distributing the minus, I get minus 3 plus 4, and this is the same as 4 minus 3, and the answer is 1. Okay. Any question for this property, for the 6 properties? All of them clear?
Yes.
Yeah.
Okay. And what about the others, other student? Clear?
Yes, it's
Brian.
clear.
Okay. So let me give example for by using this property. So the example now. So example, by using the properties in the previous, do the following: minus of x plus 2. Who did this one? And tell me which property you have to use.
I'll do it. So
Okay. Which property?
you're gonna use the addition and subtraction property.
Okay. Which one of the 6?
Fifth one. The fifth one? Yeah, number 5.
Fifth one. Because if we see the 5 minus open parentheses and the same things, minus we have parentheses and between of them addition. Okay. What I have to do now?
Yeah, so
How can I do it?
minus x. You're gonna distribute the minus.
Minus
So
x.
minus x minus 2.
Minus 2. This is correct.
Yeah.
Thank you. So the answer is minus x minus 2. We're distributing the minus inside the parentheses by using property number 6. Number 6. I mean number 5. So we have to use property number 5. Now, number 2, B. Question is minus, open parentheses, x plus y minus z. Who will do this one?
I will try.
Okay. So which property would you like to use in the beginning of this? Victoria.
I would use addition and subtractive property.
Okay, which one?
No, I think distributive property first.
Oh,
Which one?
yeah,
5
distributive
or
property, you
6?
said.
5?
Because you said why?
Which one would you like to use? 1, 2, 3, 4, 5, 6.
Oh, from these, I would use number 5.
5. So you're distributing the minus inside the parentheses. What you get?
I would get negative x
Okay.
times negative and y, so that's gonna be negative
We
y.
don't have, okay, we don't have times. Okay.
And
Then
then that would be positive z.
positive. But we have, before we have to do the positive, we have to put the minus z. We're multiplying the minus to this one. Now, which property we have to use for this one here? Minus z.
So this one is gonna be distributive property.
Which one here?
Oh, number 2,
Which one is
sorry.
number 2? Exactly. Look to number 2. Minus a equal a. So the same things here. Minus. So we have to use here property number 2. And here we have to use properties number 5. So the answer now, after we simplifying and using property number 2, I get minus x minus y plus z. Okay? Make sense?
Yeah.
Okay. Thank you.
Would you, one quick question. Would you have been able to use property number 6 for
No,
negative
you
x?
have. What's your question again? Can you repeat your question?
Sure. Would you be able to use property 6 for negative x and negative x minus y?
Property number 6, this one.
Yeah.
But here we have minus inside the parentheses. So I cannot use the property number 6. Here we have addition. That's why we use number 5. We have addition.
Thank you.
Then here we have to use property number 2. Shows here. minus times minus equal positive. Okay, so now let's go. It makes sense. Any question? Okay, so now let's go to the multiplication and division property. So after we finish the addition and subtraction property for real numbers, now we have also multiplication and division property. So here, multiplication and division property. Multiplication and division, and they are the properties. So this is the title here. Again, back, we have properties for the multiplication and division. First one is if I have fraction, so the multiplication and division property will be focused for a fraction only. So if I have fraction a over b times c over d, so the multiplication, we multiplying the numerator with the numerator for the first fraction and multiplying the numerator for the second fraction, and the same things, we multiplying the denominator between the first fraction and second fraction. So the answer here, a times c over b times d. Second property is if I have a over b. Oh, let me give you example here. Small example, easy one. So example, if I have, for example, 2 over 3 times 4 over 5. So they give me 2 times 4 over 3 times 5. And the answer is 2 times 4, they give me 8 over 15. For the second property, if I have a division a over b dividing by the second fraction c over d, so this is equal, we keep the same first fraction a over b.
Just use the reciprocal second one.
Yes, exactly, we use the reciprocal. So here we change the division to multiplication, and here we take the reciprocal, or we flip the second fraction, so over d over c. And the same idea like the first property, we multiplying a times d over b times c. Yes, we keep change flip. Yes, exactly, Ahmed. Ahmed, he said the same idea. Here we have to change the division to multiplication. Here we have to flip this fraction from c over d to d over c. Then we multiplying the numerator together, and we multiplying the denominator together.
I mean,
Small
sometimes
example. Yes, go ahead.
sometimes you can see a divided by b, and that's being divided by c, right?
A divided by what?
Let's say a divided by b, and under the same
Okay.
fraction divide by c. You can also use the reciprocal, right?
Yes, the same idea.
Right.
A divided by b divided by c, the same idea like here.
Right. It just
You
yeah.
will see a lot of question like this in web assign. A divided by d divided by c, same idea. We're going to use the reciprocal. I'm going to give example to explain how we can use this. So for example, if I have 2 over 3 again, dividing by 5 over 7. So the same idea, 2 over 3, and the division become multiplication 7 over 5. And we're multiplying the numerator together, 2 times 7, they give me 2 times 7 over 5 times 3 times 5. And the answer is 14 over 35. The question he asked me, what's your name? Who asked me this question? Like, for example, 2 divided by 3 divided by 4, something like that.
That was me.
So doing this, yeah, what's your name?
Sure.
Sure. Sure. So when you see something like that, I prefer to put the first as parentheses like this, 2/3 dividing by 4, and the same idea as 2/3 multiplying by 1/4.
Yeah, you simply just put a 1 under the 4 and then you flip it.
Exactly. Yes. This is 4 dividing by 4. We flip the 4 become 1/4. So 2 times 1, they give me 2, and 3 times 4 is 12.
That's what.
So when you see some number over number over number, I prefer the first two numbers, put it as parentheses, and you do the same idea. Yes, here I get Vivar, 3 times 5 equals 15. Yes. 3 times 5 equals 15. Yes. 3 times 5 here. Oh, sorry. 3 times 5 is E15. I'm sorry for that. So here 15. So this is here 3 times 5 is 15. And 2 times 7 is 14. Yes. Thank you. Now, question number 3, property number 3 is if I have A over C plus B over C. So look here, the denominator are equal, both of them C. So to do the summation for this two fraction, I just add the numerator. So this is equal A plus B over C. Yes. Example for this, if I have it 2/3 plus 4/3. So the denominator are equal. Both of them are 3. Both of them are 3. So I keep the 3 and just I add the numerator 2 plus 4. 2 plus 4. And this is give me 6/3. And I can simplify it by dividing both sides by 2 if I would like. So they give me 2. By dividing by 3, I mean, dividing this by 3, they give me 2. Dividing this by 3, they give me 1. So the answer is 2. The fourth property is if I have different denominator, A over B, adding to C over D. So when I have different denominator, like the B and the D are not equal, so I do cross multiply. I multiplying the A with the D, the C with the B, and multiplying here in the denominator B with the B with the D. So this give me A times D plus C times B over B times D.
You have to have the same denominator.
Yes, we have to get the same denominator, or we can do the cross multiplying. A times D plus C times B over B times D. So by this, I'm going to get the same denominator. Example for that here. 2/3 plus 4/5. So here we multiply 2 times 5, 2 times 5 plus 4 times 3 over 5 times 3, or 3 times 5. So I multiply again the 2 with the 5 and the 4 and the 4 with the 3. And in the denominator, I'm multiplying the 3 with the 5. So now I get 2 times 5, they give me 10 plus 12, 22, like Ahmed said, over 3 times 5 is 15. So the answer is 22/15. Any question until the probability number 4? Anyone has a question for 1, 2, 3, 4? Okay, Mariam. Another student, they have a question? All of them is clear? Okay, let's go to the next slide. We have two more property. Okay, so the property number 5 said if I have A times C over B times C, I can cancel the common factor. I can cancel the C with the C and I get A over B. So this property called the canceling the common between the numerator and denominator. Example for this, here example, I mean like 2 times 3 over 5 times 3. I can cancel the common factor between numerator and denominator, and this is give me 2 over 5.
It's only, you can only cancel it out when it's multiplication.
Yes, if they have multiplication, we can cancel. But if we have addition, we cannot do it. If A plus C over B plus C, we cannot cancel the C with the C. This is here not correct. A plus C over B plus C is not equal A over B. This is not correct. We cannot cancel the C with the C if there is addition. This is correct only if we have multiplication. Okay, number 6. Here, number 6. So if I have two fractions are equal, A over B equal the second fraction, C over D. Then, I mean for then, this is must. A times D is the same as C times B. I mean for that, this one times this one is the same as C times B. For example, is 2 over 3 equal 6 over 9? So to check that, I have to multiplying 2 times 9. So 2 times 9 is equal. So I have asked myself, is 2 times 9 equal to 6 times 3? So the answer here is 18. And the answer here is 18. So the answer is yes. Why? Because when we multiplying 2 times 9 is the same as multiplying 6 times 3. So the answer is yes. Other one is 2 times over 3 the same as 4 over 5. So to check that, you have to ask yourself, is if we multiplying 2 times 5, they give the same answer of 3 times 4. So 2 times 5, they give 15. And 3 times 4, they give it 12. So the answer is no. The fraction here not equal to the second fraction because the cross multiplying is not the same.
2 times 5 is 10, not 15.
Oh, again. So here 10. Sorry. So here is 10. So 2 times 5 is 10. And here 3 times 4 is 12. And 10 not equal to 12. So the answer is no here. So the fraction not equal. Any question?
just really quickly, I remember for property 4, when you were talking about multiplication and division, could you just have multiplied each side by the denominators?
Where? Which one?
For the last one, property 4.
4. So for number 4, if the denominator not equal, is not like 3. 3, the denominator are equal. C and C, here we have. When the denominator not equal, here we have C and C. So we just adding the numerator together, A plus B. For number 4, the denominator not equal, B and D not equal. So we have to do cross multiply. We're multiplying A, this one, by D, plus we're multiplying C with B, over we're multiplying B times D. This is your question?
Yeah, no, not
Could I
really.
ask?
I just because I just thought like, wouldn't you like for if they were like numbers, wouldn't you have said, if since they are not the same, you would have taken 3 and then to make them both have like the same denominator, wouldn't you have like multiplied it by 5? And then for 4 over 5, you would multiply
Yes.
it by 3.
So we
Instead
can do, yeah, I understand. Yeah, so we can here, to make the denominator are equal, by multiplying both sides by 5, like you said. If I'm multiplying the denominator here by 5 and here by 5, and here if I multiply the fraction by 3, the denominator will be equal. But sometimes the fraction is so hard to know what's I have to multiplying the denominator. Here, because the question here is easy, the denominator is 3 and here is 5. But sometimes the numbers here are huge, big. So I don't know what I have to multiply this fraction and this fraction to make the denominator are equal. So the best I have to use the property number 4. Understand? Sometimes the numbers is not easy like 3 and 5. Sometimes the numbers is so hard and so huge. For example, 120 and here 35. It's not easy to find the common denominator to multiply the both sides. So the best I have to use number 4 to cross multiplying. But if the numbers are easy, you can use your property. It's fine. You can multiplying the first fraction by here by 5 and 5, and here multiplying by 3 and 3. This is correct.
Oh, okay.
Okay.
Thank you.
No problem. Another question? No questions? Okay, let's go now to
Sorry,
the,
can you go back for a second?
yes, sure. This one?
Yes.
Okay,
Thank you. You can move on.
no problem. Okay. So now we're going to the least common denominator. Sometimes if we add two fraction and the denominator are not the same, not equal, I mean, it's not easy to do the cross multiplying. It's not easy to do cross multiplying to find the common denominator. So we have to learn a new method is called the least common denominator. So here, the least common denominator. So the least, I can set here L for the least common C, least common denominator D. Okay, What does that mean? So suppose I have example here like this, 5 over 36 plus 7 over 120. So here the denominator are a huge number, and it's not easy to multiplying the 5 by 120 and 7 by 300 by 36 and multiplying the 36 with 120 because they give me a huge number. The best idea here, we have to find the least common denominator to add this to fraction. So how we can do this? First things, we have to factor number 36. So what is the factor of number 36? How we can factor the denominator here of 36?
6 times 6.
12, 6 times 6, and what else? Ahmed, he said the 12 times 6. This is not correct, 12 times 6. 12 times 3. Yes, this is correct. So I'm going to use 6 times 6. 6 times 6. Now we have to factor 6 again because when we factor, we have to get the smallest numbers. So the factor of 6 is, what is the factor of 6?
3.
3 times 3.
3 times 2, yes. So I get here 2 times 3, and the same things for the other 6 is times 2 times 3. Now we have to order it by the smallest number. So I get 2 times 2, 2 times 2 times 3 times 3 times 3 times 3. Now we have to go to factor the other, another 120. So factor of 120. Same idea. Who will do this? Here I get a question. Could not you do 2 to the power 2 plus times 3 to the... This is correct. This is correct, but I need it in the simplest way. I need it like this. I need it like this.
So
I need it like 2 times 2 times 2 times 3 times 3. Yes, go ahead. Yes, who was in the mic? Go ahead.
Oh yeah, it would be 6 times 20, and then you would break
6.
down 6.
20. And how can I break it down?
So
What I
then
get?
Yeah, 2 times 3.
Okay, and here?
And then for 20, it would be 5 times 4.
5 times 4. Can I break it up 4?
Yeah, you break down the 4.
What I get?
And that would give you 2 times 2.
2 times 2 times 5.
Yeah.
So now we have to reorder it again. 2 times 2 times 2, 2 times 2 times 2, and 3 times 5. Okay, so now we have to cancel the common factor. So now we have to cancel the common. So I have here 2. I cancel it with this 2. Now I cancel this 2 with this one. This 3 with this 3. Now the remaining here is a 3. And the remaining here is 2 and 5. 2 times 5. 2 times 5. So I go here. I'm multiplying the first fraction for whatever is remaining for 120 after I factor. Here the remaining is 2 times 5 is 10. So I'm multiplying this side by 10 and this by 10. And the same idea for the other fraction. I go to see what's remaining for the factor 36 is 3. I'm multiplying this by 3, multiplying this by 3. Now it's easy to get 2 fractions. They have the same denominator. So 5 times 10 is 50 equal 10 times 36 is 360 plus 7 times 3 is 21 over 120 times 3 is 360. So now the denominator are equal 360. So we just add the numerator. 50 plus 21 is, what is 50 plus 21?
71.
71 over 360. We are done. So the answer is 71 over 360. This is the least common denominator. Any question?
Yeah, I'm kind of confused as to like why you multiply by 3.
By
I got 71 over 30.
71 over 30.
Yeah.
Okay. Again, we factor the 36, the denominator for the first fraction. And again, the same things, we factor 120 for the second denominator for the second fraction. The 36, we get 2 times 2 times 3 times 3 after we factor it to the small pieces. And the same things for 120, 2 times 2 times 2 times 3 times 5.
So after multiplying, if the denominator does not match up, that means you did something wrong in your LCD.
What do you mean?
No, like the question she asked, I don't know who asked. Like if let's say you get like instead of 360, you get
Yes.
250.
If you
and
get,
360.
exactly, if you get something wrong, after we multiplying the denominator, we did not get the same denominator, there is something wrong in your solution. This is correct. So
Well,
after we canceling the 2 with the 3 together, here the remaining is 3. Here is the remaining is 2 times 5 is 10. So we go here, when multiplying the first fraction by 10, whatever remaining from for the second factor. And the same things here, we multiplying both sides by 3, whatever remaining for the first, for factoring the 36. So here we're multiplying both sides by 10, you're multiplying the both sides by 3. Okay, I hope I answer your question.
yeah, so basically you switch the remainders, if that makes sense.
Exactly.
Oh.
I switch whatever he remaining 3 for the 36, right? So I multiply the 3 for 120. And the same
got
things
it.
here. Here I
Thank you.
get 10. Here I get 10. For 120, I multiply it for the 36 fraction. So I switch. Any question?
Can you say 71 over 30 is correct?
71 over 30, this is not correct. The answer is 71 over 360.
Oh. Can I say how I got that? And then you could say where the wrong part.
Okay, for the 36, we multiplying by 10, I get 360. For the 5, I'm multiplying by 10, I get 50. Same things for 7. 7 times 3 is 21. And 120 times 3, they give me 360. So now the 360 for the same denominator, just I add the numerator, 50 plus 21, I get 71 over 360.
Because I simplified the denominators. So 12,
No,
for
you
example,
cannot.
12 goes into 36 3 times, and 12 goes into 120 10 times.
No, you cannot.
You can't do that? All right.
No, you cannot. I know what you do. Here you cancel it, the 0 with the 0. And here I don't know what you cancel exactly to get the 36. But after that, you get the same answer, 71. This is not correct when you get 71 over 36. The best idea, use the same things. Don't simplify anything. Just you multiplying, you get this one, you added the second fraction. And both the same denominator. Okay, any question? Okay, let's now go to the sets and intervals. Here, sets and intervals. Sets and intervals. So Who have any idea about sets? What is the meaning of sets in math?
Sets are a set of, I think, sets are a set of numbers.
Yes, exactly, numbers, or if we do not talk about math, it's like objects.
Yeah.
Like collection of objects. So I can say here sets is collection
Collection of objects.
of objects. So, but in math, object in math called elements. So the collection in math, the object in math, I call it element. For example, if I give you the set A equal 1, 2, 3, 4, this is the set A, okay? This set has number 1, 2, 3, 4. So I can say the number 1 is element. And number 2 is element. Number 3 is element. So number 1 is an element of A, inside A. But I can say number 5 is not an element of the set A. It's not inside of A. This is mean is an element. Sorry, this is an element inside the set. Here, this is not an element inside the set A. This is what you have to know about set. Now let's go to the intervals. Any question for set? Make sense what I said here? Intervals. So we have two kinds of intervals. We have two kinds of intervals. We have a closed interval and open interval. So here I can say I have closed interval. Can use the black color. We have close and open. So closed interval and open interval. Okay, I'm going to explain what is the meaning of a closed and open interval. But any idea? Anyone has any idea from high school what is the meaning of closed and open interval?
I think a closed interval means including the first and second element in the set. And
Exactly.
Open means you're
not including.
Right.
Not including. Yes, this is correct. The first and second element, this is called the endpoint. So for a closed interval here.
Sir, can you go back?
Yes. Oh, sorry. Yes, sure.
Thank you.
No problem.
You go forward.
Yes, for now, a closed interval, it's something like this. The notation is something like that. If I have two elements, A, B, and this is mean closed interval. I mean all the element between the first number and the second number, and also including the endpoints, including A itself and B itself. This is what I mean of a closed interval. So here I can say I can define it as all numbers from A to B and including the end points A itself and B itself. Okay, but for open interval, open here, open interval, it's something like this. Open parentheses, like this. A comma B is all numbers from A to B without the endpoints. Without the endpoints A and B. I mean, like if I have a closed interval from 2 to 5, I mean all numbers between two, all real numbers, I mean for numbers, I mean real numbers. All numbers between 2 to 5. I mean like 2, 2.5, 2.6, 2.7, 3, 3.1, 3.2, until 5. And also number 2 are including inside the interval. Like I mean the 2 is inside this interval and the 3 and the 5 is inside this interval because both of them are endpoints. But for the second one, if I have open interval from 2 to 5, the 2 and 5 not including inside the interval, but everything between 2 and 5 are included. I mean like 2.1, 2.3, 2.5, 2.6, 3, 3.1, 3.2, all these numbers are inside this interval, but the endpoints are not in this intervals. I can define the closed interval, this one, A comma B, as like this, x such that x between A and B. And for the open interval A comma B, this is called set description. I can define it as x such that x between A and B, but here we don't have equal at for A and B. But for the second one, we have equal. Here we have equals, but here we don't have equal. This is the difference. And the graph for the first one here, if we need to graph it, would be something like this. Here, all elements between A and B and A are included. So this is my A, it's closed ball, closed small ball, and this is B, is also closed ball, and all elements between A and B. All elements between A and B. For the second one, at A is open circle, and at B is open circle. So, but all elements between A and B are in the set, are in the intervals. So here is included. Is it clear? So this is a closed interval and open interval. A lot of questions you will see in the web assign for closed and open interval. Yes, go ahead.
So basically, if it's like in brackets is closed, and if it's in parentheses is open.
Yes.
Okay.
Sometimes you can have closed and open in the same set, right?
Yeah, like I was gonna
Yes,
ask that. Like if
yes,
one
I will
side
show
has
you
a bracket
how
and one side has a parentheses, will it be like that?
this is. Yeah, this is correct, Justin. Sometimes and one side is open and the other side is closed. So can I move to the next slide? Can I move to the next slide? Okay. So here I'm going to give you a table for examples for intervals. So here we have the notation. Here we have the set description. We have the set description. Here we have the graph, and the first one is the notation. Notations. So for the first notation, suppose I have, like some of you said, I have open here. I have open interval at A, comma, and close at B. So the set description for this will be something like that. All values here means between A and not equal, and B is equal. I mean, for B is inside the interval. The graph for this will be one side has open ball and the other side has closed ball. So the one side at A will be like open. This is A here, and this is B. So at B is closed, and all element between A and B. All element between A and B. The other notation I have, if I have open at A to infinity, this is mean all elements starting from A to infinity, and A is not included in the interval. I can set description by X such that X is greater than A. I mean, for all element starting from A going to infinity. So starting from A, and A is not included. We don't have to put the equal. So the same things for the graph. Here for graph will be from A. So A is open circle, goes to infinity like this, rows like this. So will be something like this.
And
Okay.
you can never include infinity, by the way.
Infinity not included all the time.
Yeah.
Okay. Okay. So the third one, the last one, before we're going to end this lecture, is open parentheses at minus infinity to B. So this one, I can describe it as X such that X is less than or equal to B. So the graph for this one be all the numbers starting from B and goes down. So this is my B, and B is including also. So B, here is B, close ball, and all elements is smaller than B, goes to infinity, to minus infinity. I get question, open circle on the left, close circle on the right. I mean, for open circle is open, the interval is open, A is not including, that's why it's open. But when it's include, will be close. Okay, Dilian? Make sense? Okay. Let me give you small and easy examples. This is the last examples here. So the interval 1, 2 open. What does that mean? Who will do this one? What does that mean? It's similar to the first notations.
I'll try.
Yes, okay.
So x such that
That
1 is less than x.
equal or not at 1?
Not equal, just less.
Is including, right?
I see. Sorry. Yeah.
Exactly. So
That's what-
it's equals. Yes.
It's a bracket, not a parenthesis.
Yeah, it's less than 2.
Okay, exactly. Thank you. So the graph, the same things. We have to do a line at 1 is a closed ball, closed small ball. So here is closed at 1, and at
Open it.
2 open it. Yes. So we have 2 is open, and we have to draw a line between both small balls like this. Thank you. So now last example is a small one again. Is number B. This is A. Here, open parentheses from -3 to infinity. Who will do this one? Who will do
I'll
this
do it.
one? Yes, okay.
So
X.
x
Yes.
is negative infinity. No. -3
Okay. Like
is
I have,
is less than x,
okay.
which is less than or equal to infinity.
Less than infinity. But we don't have to write the
Oh
infinity.
yeah, just
So
less
we
than.
Exactly. So we can remove it. This is correct. Now, how we can graph it? Here, we don't have to put the equal. Why? Because it's open parentheses. So how can we graph it?
So it's gonna be open at -3.
Yes.
And it
open.
goes left. Actually,
Open.
right. Sorry, it goes right. The arrow.
Yes. So the arrow to the right, like this. Okay, we finish up to here today, and I'm going to see you next class Thursday. Okay?
Yes,
Have a good
sir.
day, everyone.
All
Have a
right,
good day, everyone.
Bye. Have a good day.
You too. Have a good day.